Hi scholars, happy Friday. Today we're going to be reading Chapter 3 in Unit 9, A Fossil Goes Missing. Make sure you check the video description below. We're going to have a link to our reader. Next Monday, I'm going to state this up front just so you're not surprised. This following Monday, we're going to have our iReady ELA final diagnostic. So if you were really happy with how well you did on that last one in the middle of the year, I'm sure you guys are going to do excellent on this final one. I can't wait to see your results. I'm going to send out a video and then some phone calls on Monday as well to remind scholars about it. But in the meantime, make sure you have your packet ready. And then we're going to dive in right now to Chapter 3. First step for the day is our do now. So you're going to be combining following short sentences, but you're going to use commas and transition words to create it into one big sentence. So we have three kind of fragments that we're combined into one big one. Felix got excited, Felix fell down, and lastly, he was found in a gully about 10 feet deep. How can we combine all three of these sentences into one sentence? Check the graph here as well for some commas and some transition words and grammar techniques. You can use a comma, you can use ellipses. I would even recommend a colon. Really not going to use anything like an exclamation point or question mark for this right now. Looking at our daily objective for the day, I can use text evidence to classify metals and non-metals applying sentence combination. So we practiced some sentence combination before. Today we're going to talk about the differences between metals and non-metals. It's usually pretty easy to tell by some physical and chemical differences. It's not going to be that difficult. You're usually able to look at something, look at the physical traits, and be able to tell right away if it's a metal or a non-metal. Let's review our vocab first. We have a little bit of word work. Vocab. Our first word is slathered. It's a verb. It's to spread on thickly. Some people might like to slather on a lot of peanut butter on their PB&Js or slather on some butter. It all depends. Slather. Think of even if you're working on a sidewalk, they slather concrete to create the sidewalk. Furnace. We all know what a furnace is, or we've heard of it before. We have one in our school. It's a very hot oven. It's what supplies the heat throughout a building. Atoms. Atoms is the basic unit of an element. So we talked about how everything in the world has matter. Atoms are the tiny little building blocks of life that make up this matter. So everything in the world, if you use you can't even see it unless you have a super powered microscope. At the very base of everything are atoms. They're so small, it's incredibly possible to see, but everything in the world is made up of atoms. The periodic table is a way of organizing chemical elements. It looks like a big graph. It puts all the elements or the chemical elements in our world in one place. Resonance. If you like music a lot, you've probably heard some songs with really good resonance. It's a quality of sound. It's usually when something is clear, deep, and long lasting. If you've ever tapped on something that's metal and hollow, think of like a railing going down a staircase or something, and it goes like dong. If you ever ding on a metal thing and you hear it echoing for a while, that's the noise resonating or bouncing around inside of it. Conductor. A conductor is a good channel for something. So it's a way of connecting to things such as electricity or heat. So water is a good conductor for electricity. It's a good channel. It's a way for water, electricity to move is to go through water. For heat, a good conductor might be something like wood, some dry leaves. It's something that channels the element and allows it to keep going. And lastly is tense. It's an adjective, tense. Say nervous or tightly wound. So your word work, I want you to finish the sentences. What sound have you heard that has resonance? What sound have you heard that has resonance? So think of anything you've heard before that sounds like it's clear and it's echoing. And then when was there a time that you felt tense? Remember, tense is nervous. Today we're going to be reading Chapter 3, pages 16 to 21. Our big question, which we just talked about, is how do we keep track of all the elements? There's a decent amount of them. We actually use something called a periodic table. Periodic table is a graph that we use in science to keep track of all these elements. All items in the world are made up of these elements. So maybe it's a combination of some magnesium, some lead, or some oxygen and carbon. Even the air and water And the world around us is made up of these elements. Every metal, the table you're sitting at, the chair you're on, the computer you're using, everything is made up of these elements at the very base form of them. These atoms make up these elements. Let's take a glance at it first before we start our chapter. So you have this in your packet as well over the next 2 pages. I don't expect you to memorize all this. Mr. Sheehan doesn't even have this memorized. If you're a scientist, you probably do though. This is the periodic table of elements. So this lists off all of the elements that make up our world. In the top you see the key. That lets you know what each number and letter means. So the relative atomic mass, that's how heavy it is in terms of atoms. The atomic symbol is usually just like the nickname or a way of shortening it. So if you look at the very top there, hydrogen, it has 1 atomic mass. Whenever you see just an H, it means just hydrogen, and they write it beneath it. And then the atomic proton number, which we'll talk about later, is 1. We're going to use this information later, but take just a moment, pause, and look at some of these elements in your packet. You probably recognize a couple of these. Things like if you look at 207 in the bottom right corner, 207 Pb is lead, so it makes up our pencils. You have things like iodine, so it makes up medicine. You have things like chlorine, which they use to clean a pool, fluorite, which is used in toothpaste. You have iron and cobalt. These are metals that are used. Let's take a moment now to open our reader up to page 16. Open the video description beneath you to find a link. Chapter 3, A Fossil Goes Missing, starts on page 16. I'm going to begin reading. I'd like you to follow along. Dr. Forrester doesn't look very happy this morning, said Felix as he poured milk on his instant oatmeal and passed the carton to Amy. She followed Felix's gaze. Dr. Forrester was standing outside the lab with Tess, gesturing and shaking her head. Matt slathered butter on a piece of toast. Julian had made himself a peanut butter sandwich, and Daria was munching an apple. The only one who wasn't eating was Crystal. Wearing her dark sunglasses, she silently sipped a cup of hot tea. Before breakfast, Crystal had been sitting on her cot, working on a sketch. When Amy had asked to see what she had drawn, Crystal had pulled the sketchbook tight to her chest. Amy had wondered why Crystal would be so secretive about her drawings. Dr. Forrester finally came over, pouring herself a mug of coffee, and joined them at the table. One of the little fossils from the gully seemed to be missing. She lifted the cup up but set it down again without taking a sip. I could have sworn there were 6 fossils. This morning there were only 5 on the table in the lab. Did you search the tent? Julian asked. Dr. Forster nodded. And now Tess is searching it again. The thing is, I could be mistaken about the number of fossils. There might have just been 5 to start with. Still, it's a bit of a mystery. At that word, mystery, Amy started to tingle all over. A missing fossil? Now that was something she could get interested in. Amy thought about Inspector Ellis and his notepad. She suddenly remembered she tucked a small notebook inside the front pocket of her backpack just before she and Matt had left home. It would be perfect for recording any clues she might uncover regarding the missing fossil. Excuse me, she said, pushing her chair from the table. I need to get something from the tent, but I'll be right back. Amy sprinted to the tent and retrieved the notebook from her backpack, along with a mechanical pencil. As she turned to leave, she spotted Crystal's sketchbook lying on her cot. Before Amy realized what she was doing, she opened the sketchbook and flipped through the pages till she came to one full of detailed drawings of the little fossils from the gully. There is a drawing of 6 fossils, not 5. So there was a fossil missing. Amy put Crystal's sketchbook back where she had found it and hurried back to join the others. On the drive out to the dig site, Amy clutched her notebook, lost in thought. How had the fossil gone missing? Had someone taken it? And why hadn't Crystal mentioned her drawing to Dr. Forrester? You look better today, sis, Matt said, interrupting the stream of questions running through Amy's head. Yesterday you looked pretty unhappy. Amy smiled at her brother. Today's different, she thought. Today there's a mystery to be solved. When they arrived at the dig site, Dr. Forrester suggested they spend the morning continuing their excavation. After lunch, when the afternoon sun was tucking the narrow plateau into a furnace, they scoured the gully. Maybe we'll be lucky and find more small bones, she explained. Amy noticed that the plan seemed to please everyone, especially Julian. He pulled out his pick and brush and set to work before anyone else. After a while, he paused and looked at Tess. Yesterday you were talking about how matter can change states, but what makes one kind of matter different from another? What makes this pick different from, say, a rock or fossil bones? Tess rocked on her heels, wiping the sweat from her brow. Before I can explain that, we need to fill in a few background details. Remember when I said that matter was made up of small particles? Those particles are called atoms, which are so small they're invisible to the naked eye. There are more than 100 different kinds of atoms, and each kind is called an element. But aren't atoms composed of even smaller elements called protons, neutrons, and electrons? Indeed, they are, Tess agreed. But an atom is the smallest amount of any element that shows the properties of that element. Elements, then, are the basic substance that makes up matter. Think of them as the basic ingredients of matter. All the known elements are arranged on something called the periodic table of elements. We have one of those hanging on the wall of our science classroom this year, Crystal said. Excellent, exclaimed Tess. Then you may have noticed each element has a name and a symbol made up of one or two letters. For example, oxygen is an element and its symbol is O. The element's nitrogen symbol is N, and the element aluminum symbol is Al. The elements are arranged on the table based on their properties and certain patterns in their atoms. Tess grabbed her rock hammer and held it up. That brings me to your question, Julian. The elements are often divided into two groups, metals and nonmetals. The head of this hammer is mostly made up of the element iron. She flipped the hammer upside down. The wooden handle is mostly made up of nonmetal elements, such as carbon, nitrogen, sulfur, and phosphorus. Felix suddenly started digging out his digging tools and arranged them in a line on the ground. Ever notice how a metal object makes a nice sound? He asked, with a mischievous look on his face. He began tapping his chisel against all the other metal objects like he was playing a drum. Each one gave out a clang when he struck it. If the paleontologist doesn't work out for you, Felix, maybe you have a future as a musician, Matt joked. Then again, maybe not. Felix made a face at him. Felix is right, though, Tess broke in. That ringing sound, scientists call it resonance. It's a property of metals. Being shiny is another. So is being malleable and ductile, which means that you can hammer metals into shapes and stretch them out into long, thin wires. If you've ever seen the inside of an electrical cord, you've probably noticed the metal wires inside. Another property of metal is that they're good conductors of electricity and heat. Tess picked up a piece of sandstone and set it on a flat space beside her. Nonmetals, on the other hand, have very different properties. They tend to break or crumble, not bend. She hit the rock with her hammer, and it shattered into pieces. They also don't conduct electricity. They're usually dull rather than shiny. Dull means not bright. And they lack the lovely resonance. She tapped her hammer on her water bottle, and it made a dull thunk. Amy noticed that Dr. Forrester had been listening to Tess, but she walked over suddenly to the far side of the plateau. Now she was returning, in a hurry. Change your plans, everyone, she said breathlessly. There's a storm coming. She turned and pointed towards the northwest, where a line of dark clouds hugged the horizon. Even as Amy watched, the clouds seemed to expand and move closer. I'm afraid it's moving directly towards us, Dr. Forrester said, untying the lines that held the tarp over the dig site. And when it hits, we don't want to be standing here, exposed on this plateau. Why is that a problem? Crystal asked. Tess summed it up in one word. Lightning. Crystal's eyes grew wide. So we're going to the back camp where we'll all be safe in Kent's? Weren't you listening to the chemistry lesson? Felix called out as he ran over to help Dr. Forster with the tarp. The tents have metal poles, and metal conducts electricity. At home, we go into a basement when a bad storm is coming, Darius said in a tense voice. And in a way, Dr. Forster said, stuffing the folded tarp into her backpack, that's exactly what we're going to do. Everyone grab your gear and follow me. She led them to a spot where Felix had slid down into the gully. The wind was blowing much harder, and the storm now half covered the sky, like a huge black curtain sweeping towards them. Yesterday, when I was walking along the gully, I spotted a shallow cave near the end of this ridge. Dr. Forster had to shout to be heard over the rising winds. Climb down carefully. It's slippery. You could say that again, yelled Felix. Amy kept her eyes on the storm as they hurried along the dry gully. Bright chains of lightning zigzagged through the steely gray clouds that were quickly approaching, and she could hear the deep rumble of thunder. By the time they reached the cave, the storm had blotted out the sun. They scrambled up the rocky hillside and stepped beneath the cave's shelter overhang just as the first raindrops began to fall. Move to the back, Dr. Forrester shouted above the booming thunder. They huddled together in the deepest corner as the storm struck. Rain fell in great swirling sheets. Bolts of lightning and flash and thunder crashed so loudly that Amy had to cover her ears. Gradually, the rain began to let up. The rumble of thunder grew more and more distant as the storm slowly moved off. Dr. Forrester stepped into the front of the cave, and the others followed. Everything looks so much more colorful, Crystal said, as the sun came up, like the rain washed it clean. It might have done more than that, Dr. Forrester mused. Rain erodes these rocky ridges and loosens fossils hidden inside them. Sometimes, she paused and looked thoughtfully at the gully before, it washes fossils down the ridges into low spots. Felix was the first to understand. You mean we might find more of those strange little bones in the gully beneath the dig site? Dr. Forrester gave a quick nod. Exactly. So if you all don't mind getting your boots a little money, let's go on a fossil hunt. Before we start labeling what is a metal and what isn't a metal, we have a chart right here I'd like you to fill in your packet. So a metal makes a resonant ringing noise, and non-metals don't make a ringing noise. So I have some examples I'm going to use. I got some tools out of my own little toolkit. I have this hammer here. It's got a metal top. It's got a plastic handle. And then I have this scraper here, like for paint. Again, it's got a plastic handle and a metal top. Then I can use a pencil as well, so we can discuss what is and isn't a metal and check these properties. So, malleable. It means it can be hammered into shape. I mean, think of a hammer. A hammer uses a nail, which is made of metal, and it hammers it down. It can be changed and moved. It's ductile. It can be pulled into a wire and conduct electricity. Like they talk about in a story, if you ever open up like an electric, like a wire or a cord, if you've ever seen a cord that gets like frayed, you can see the little metal wires running inside of it. They're conductors. They conduct electricity. You're not going to use plastic to conduct electricity. You're going to use metal. And it's shiny. Look how shiny even this hammer is and the little bit of light I have. You can see all the light reflecting off of it. And then resonant, let's test it. It makes a ringing noise. So I'm going to take my scraper here. I'm going to take my hammer. You can hear kind of a little bit of ringing. I even have a candle topper here that's made of metal as well. Actually, this is made of plastic, so we can hear the difference. This is metal hitting metal. Sounds like a ringing noise. And then listen to the thunk on a non-metal, or even on a pencil. It doesn't sound very resonant. It doesn't really ring. Doesn't sound like it's echoing either. So we're going to use these following traits. Our next few activity pages are going to give you a description of an element, and then it's going to want you to tell. It's going to want an answer to tell: is it a metal or non-metal? And then what traits does it have? Wrapping up for the day, make sure you finish page 101 and 102. Remember, you need to list the element's name. That's easy. They tell you what it is in the description. List what traits or characteristics it has. Again, that's in the description. And then you have to make the call. Is it a metal or a non-metal? Look back at our graph to see which one you think it's likely to be. At the bottom, there's a challenge I'd like you to do. Once you complete it, you can take a photo and send it to me. I would like you to come up with your own description. So you're going to pick an element from your own table, from the periodic table, and then you're going to have to list the element's name, what kind of traits it has, and then if you think it's a metal or a non-metal. I would actually pick a fun one like oxygen or helium. Pick a gas, not a solid. So helium is actually the type of air they use to pump into balloons. And think back, if you've ever actually blown up a party balloon before, what happens if you actually inhale helium or if you swallow the air that comes out of a party balloon? Remember, not a regular balloon that you use your mouth, but helium, the gas that gets pumped into it. Think about what that does to the balloon and how that can have a chemical change. Also, on Monday, we have our final diagnostic on iReady. So make sure you sign on then. There'll be a video to go up and there'll be texts and phone calls going out as well. Super important that you get that one done. It's not going to be open for long. We're not able to keep that one open like Edge Elastic. In the meantime, scholars, if you have any questions, go ahead and give me a phone call. I look forward to seeing the pictures of your completed work for pages 101 and 102. Thank you and have a great day. Bye-bye.